Hey everyone, so today we are going to be graphing quadratics, but this time in vertex form. Alright, so I want you to pause the video and try this do now. So this is a practice SAT question. So it's saying that ax plus 2 times bx plus 7 equals 15x squared plus cx plus 14. And it also is saying that a plus b is 8. So what are possibilities for c? So if a plus b is 8, right, and this first term is 15, that means what do a and b have to be? They have to be 3 and 5, right? 3 plus 5 is 8, and then 3 times 5 is 15. So that means this could be 3x plus 2 and 5x plus 7. So it wants to know what's that middle term if we multiply this out. So that gives us 21 and 10. 21 and 10 gives us 31x. So that means it's D. If you switch your 5 and your 3 and you did 5x plus 2, 3x plus 7, that gives you 35x and 6x, which adds up to 41x. Okay, so I want you to start. We're not going to graph these. I just want you to find the vertex. Right? So pause the video, negative b over 2a, and then plug in. All right, so again, negative b over 2a. So I get negative 4 over 2, so negative 2. And then I'm going to plug in. When I plug in, I get 4 minus 8 minus 3, so that's negative 7. This one, negative 12 over 2 is negative 6. Plug in negative 6 and I get 36 minus 72 minus 5. So what's that? That is 36 minus 77. What is that? Negative 41. 41. Yeah, negative 41, I think. Sometimes I can't do math in my head. 36, oops, minus 77. Yeah, I'm right. Okay, I got nervous there. All right, and then last one, negative b, negative 6 over 2a. Ooh, this one's a fraction. So that's negative 3 over 2. And then when I plug negative 3 over 2 in, let's see. 2 times negative 3 over 2 squared, 6 times negative 3 over 2, minus 18. I get negative 22.5. Right? So all that is was going through and finding the vertex. So now, I want you to complete the square. Do not solve. We're just going to complete the square. So remember, completing the square, x, we're taking half of 4, x plus 2. We put an extra 4 into the problem, so minus 4 minus 3. So x plus 2 squared minus 7. Next one. Half of 12 is 6. Minus 6 squared minus 5. So that's x plus 6 squared minus 5. This is the hard one. We have to divide everything by 2. X squared plus 3x minus 9. Half of 3 is 3 over 2. Then we have to do minus 9 over 4. And then I'm going to combine that with the 9. That over 4, that's going to be 36. So we get x plus 3 over 2 squared minus 45 over 4. And then we have to put that 2 back in the problem. Minus 45 over 2. That's it. Okay, so now look back. Look back at that previous slide. What was the vertex of number 1? It was negative 2, negative 7. What was the vertex of number 2? Uh-oh, I have a mistake here. It was -6, -41, because I can't add together. -36 and -5 is -41. JK. So it's a 41. Alright. And then the last one was -3/2. 22, -22.5. Okay. So now look at these. So when we complete the square, that is vertex form. But what do you notice? You hopefully notice something. We have +2, -2. +6, -6. +3/2, -3/2. So you do have to change the sign of the x. Because what's really happening here, if I plug in -2 into this top one, I get 0, right? 0 - 7. So the outside stays the same, but the inside ends up changing sign. Because basically it's a translation. We're translating the problem, the parabola. All right, so when you complete the square of a quadratic, you are writing it in vertex form. So this is vertex form. Oops. And the vertex is HK, right? So H is, you change the sign of the negative, so it's positive H, and then the K stays the same. All right. So now let's graph this. This is the parent function, right? This is the most basic parabola you could graph. You can't get any more basic than just x squared. So what's the vertex of x squared? -b/2a. Well, there is no b value, so it's -0/2 times 1. So 0, -1, 1, -2, 2. This is pretty basic. When I plug in, I get 4, 1, 0, 1, 4. So -2, 4, -1, 1, 0, 0, 1, 1. And then we can do 3. What's 3 squared? 3 squared is 9. -3 squared is 9. So this is called the parent function. Every other parabola is based on this. Basically, every other parabola is you just pick this up and move it around, right? So it's 0, 0. If my vertex was 4, 2, it would just be right there. If my vertex was -5, -3, it would look like that. So every parabola is this. So when you move it, notice that the relationship between the points is the same. We still have this point that goes from the vertex over 1 up 1, over 2 up 4, over 3 up 9 in both directions. So we're going to use that fact to graph these. All right, so all we're going to do here, so based on what's the vertex? Start with the vertex. What is the vertex? The vertex, change the sign of the inside to the outside is -9. That's my vertex. So I'm going to plot that point. Now this is based on the parabola x squared, right? There's no number in front of x squared, so we don't have to worry. So remember, our table for x squared was 0, 0, 1, 1, 2, 4. But in both directions. I'm only going to write the positives. So from my vertex, I had that point 1 squared is 1. 1 squared is 1 over 1 up 1. 2 squared is 4. 1, 2, 1, 2, 3, 4. I'll show you what I'm doing. I'm just counting from my vertex. 1, 2, 1, 2, 3, 4. So it's at -5. Back to my vertex. There's my pointer. So I'm going to go 1, 2, 3, and then up 9. 1, 2, 3, 4. It's on the x-axis. 9. Oops, I'm not blue anymore. 3, and then same thing, back to my vertex, over 3, up 9. And there's my parabola. So this is all based on the fact that this is what the parent function looks like. we just took our parent function, which has that table, you know, -2, -1, 0, 1, 2. I don't do the negatives because when you square it, it's the same thing, right? So if I can just pick this thing up, see if it'll let me do it. This is the parent function. It was just moved over 2, down 9. And that's my new parent function. So now I can look at this, and what are the roots? The roots are where it crosses the x-axis, so -1 and 5. What is the y-intercept? 0, -5. The symmetric point was 4, -5. I'm just looking at the picture. My axis of symmetry, x equals 2. Now, how can I find the y-intercept without looking at the picture? What would you do? Well, the y-intercept, the x value is 0. So if you find f of 0, just plug 0 in. You get 0 minus 2 squared minus 9. So that's 4 minus 9 is -5. So it is a little more difficult to find the y-intercept when it's in this form. Okay, so now let's try this one. Same idea. So start with your vertex. What's the vertex? It's -5, 4. So now we're going to be using that shifting rule. So I always make my shifting rule, I write it out as over and up. It could be down. And then it's based on the x squared, right? So 1 squared is 1, 2 squared is 4, 3 squared is 9. So I'm going to plot my vertex, -5, +4. Now this one is slightly different. Why is this one different? It's got a negative in front. What does that tell us? Instead of going up, we're just going to go down. Okay? So I'm going to go from my vertex, over 1, down 1. Back to my vertex, over 1, down 1. Always count from your vertex, right? So from our vertex, over 2, down 4. Back to our vertex, over 2, down 4. Back to my vertex, over 3, down 9. Now sometimes I'll do the math and if I don't feel like counting, because this is 4, so I'm at -5. Let's see, -5, -5. And I usually do as many as I can fit on the graph. So I do a little bit more than when we did with the table. I usually like to do the 3, 9 if I can fit it. All right, so then write down what are the roots, y-intercept, so this one we can't figure out the y-intercept by looking at the picture. So my roots are -3 and -7. My y-intercept is -25 plus 4, so 0, -21. The symmetric point would be double the vertex, -10, -21. Axis of symmetry, x equals -5. Alright, now we're getting a little harder. Vertex is still the same. Remember from when we completed the square. The vertex is still exactly the same. -1, -3. But remember what happens when there's a number in front of x squared. What happens? It becomes skinnier. The y value goes up. So here's what we do. Over, up. I'm going to use my normal shifting rule. 1, 1, 2, 4, 3, 9. However, we need to multiply our y values times 3. Because there's a 3 in front, I'm going to multiply each of these by 3. Times 3, times 3, times 3. Because my y values are going up. So my vertex is still -1, -3. But now instead of going over 1, up 1, we're going to go over 1, up 3. Over 1, up 3. Over 1, up 3. And then over 2, up 12. Over 2, up 12. So I'm at 9. And then I can't fit the 27, right? That's too much. And that's my parabola. So it's just a skinnier version. All right, so what are my roots? 0 and -2. My y-intercept, 0, 0. The symmetric point, -2, 0. X symmetry, x equals -1. That's it. All right, I want you to pause the video and try this one on your own. Remember, we're changing our shifting rule a little bit. So over, up, 1, 1, 2, 4, 3, 9, because all of this is based, again, on x squared. 1 squared is 1, 2 squared is 4, 3 squared is 9. So now we have to multiply by, we have a -2 in front, so I'm going to do times 2, times 2, times 2. So that's 2, 8, and 18. My vertex, change the sign of the inside, 7, 8. All right, so from my vertex, now you can either make it negative, different students understand it differently. I just change it to down. So I think of it as down 2. You could also think of it as up -2, which is, just the opposite. Like some kids multiply by -2. It's really what makes sense in your brain. I just keep in my mind, it's times 2, and I just need to go down. So over 1, down 1, over 1, down 1. Over 2, down 8. Over 2, down 8. Ooh, we could fit 18. They're right there. And there's my parabola. A lot easier, right? Ooh, what is my y-intercept? -2 times 49 plus 8. -98 plus 8 is -90. My roots are 5 and 9. We don't really need the symmetric point here. If you want to put it, I don't think I put this on the quiz or the homework. We don't need the symmetric point for this. There's no point in writing it, but it's on here. And that's it. All right, last one. Pause the video. Try it on your own. All right, so now this one, it's so easy it's hard, right? Because what is the vertex? Notice there's no inside. There's no b value. If you try to do -b over 2a, there is no b, so it's 0 over 10. So your vertex is 0, comma, -1. So anytime there's no parentheses, it's just 0, and then this is my y value. So 0, -1. Now I have my over, up. One, 1, 2, 4. I'm just going to do those because we have to multiply our up by what? We're multiplying by 5. So we're not going to be able to fit a lot on here. We can really only do the 1, 5 because I can't go over up 20. So over 1, up 5, over 1, up 5. So these are really, really skinny because of that x to the 5th. Right. Our roots, I have no idea. We would have to solve that, right? So for me to find the actual roots, I would have to do 5x squared minus 1 equals 0. It's actually not that hard to solve. X squared is 1/5. So we get x equals plus or minus the square root of a 5th. Oh no, what is wrong with my pen? It won't let me write. There it is. Plus or minus the square root of a 5th. My y-intercept is -1. There is no symmetric point because the vertex is the y-intercept. X is symmetry, x equals 0. Right. And that is it. So, practice using a table. Have a fabulous day, guys.